All right, hello, welcome to 90.9, the quadratic for your honors algebra 2 rational functions test review packet. That's Stanley in the background, wishing you luck tomorrow. Got an open note test on Tuesday. This is what I'm giving you tomorrow, Monday in class. You might not be able to get all the answers in class. Here are all the answers. Again, anything you have in possession that is yours, you may use tomorrow. Guys, 1 through 6, you just need to find any points of discontinuity. That's anything that makes the denominator 0. Remember, that is a math sin. You cannot divide by 0. So you simply set the denominator equal to 0 and worry about nothing else. You don't have to describe it. You don't have to call it a whole or an asymptote. You just simply set the denominator equal to 0. You should get these answers in class. Here they are for the first 6. You could get fractions like number 4. That's no big deal. Could have multiple answers like on 1 there, but here's the answers for 5 and 6. All right, now it is on 7 through 9 that you do have to describe what the answers are. Remember that asymptotes don't get canceled, so you need to factor. When you factor the denominator here, or the numerator in some cases, notice that the x minus 3's cancel. If you set x minus 3 equal to 0, you get x is 3. Because it canceled, that's why it's a whole. Because this x plus 3 equals 0, which is x equals negative 3, did not get canceled, that's a vertical asymptote. Notice that the 2x plus 1's get canceled. If you set them equal to 0, you get x equals negative 1/2. That makes it a whole. X equals 4 did not get canceled, so it's a vertical asymptote. Lastly, here you have x equals 0, you have x equals negative 5. You can find those first. Notice how the x's cancel. That's x equals 0. That makes that a whole. X equals negative 5 is a vertical asymptote. All right, moving on to the second page. This was a little bit of a struggle for us on the first quiz. Simplify the rational expressions. Guys, you're just factoring the top and the bottom. Factor out a 25 from the top, and they will cancel north and south there on number 10. Factor out a 4 in the numerator, number 11, a 7 in the denominator, number 11, and the x plus 2's will cancel. Factor out an x in the numerator on 12. That's the difference of two perfect squares on number 12 in the denominator. X plus 6, x minus 6. The x plus 6's cancel. Number 13, we'll multiply this to 32 because it's negative, differs by 4. That'd be 8 and 4. 8's positive. Difference of two perfect squares down below. Notice how the x minus 4's cancel. That's your answer. You got to factor twice, 14. What multiplies to 42 adds to 13. That is 7 and 6, both positive. What multiplies to 18 and adds to 9? That's 6 and 3. You got x plus 7, x plus 3. On 15, you got to factor out the 3 first, then you're left with x squared minus 9, and then that will factor to be x minus 3, x plus 3. What multiplies to 6 because it's negative, differs by 1. That'd be 3 and 2. The middle term's negative, so the bigger factor, 3, is negative. All right, the x minus 3's cancel. You're left with 3 times x plus 3 plus x plus 2. All right. 16 through 23, multiply or divide and simplify your answer. It's all about factoring, folks. It's all about factoring. Factor the numerator and denominator. Take out the 3 from 3x and 3. Take out the 2 that they share. Everything's going to cancel but the 3 and the 2. All right, on this one, folks, can't do anything with 4x cubed. That's going to stay the same. Difference of two perfect squares. Factors like this. Multiplies to 12, adds to 7, 4 and 3. Now it's time to cancel. The x plus 3's will cancel. You have 3 x's up top. You have 2 x's down below. That means these 2 at the bottom will cancel with 2 of them here, leaving you with this answer. All right. Here we are on the next page, more of the multiplying. Just factor here. Take out the x they have in common. Difference of two perfect squares. You can't factor any of this. The x plus 4's cancel. The x minus 4's cancel. You have 2 x's down below. 1 up top, so this one cancels with that one. Left with, if everything cancels in the numerator or denominator, that's not 0, you're left with 1 over 3x. All right, then on anytime you divide with fractions, you got to multiply by the reciprocal. So the second fraction, flip it. You have y to the 11th up top, y to the 7th down below. That means there's 4 more y's up top. Down below, you have 1 more x if you have 4 down there, and 3 up above, and start canceling numbers. 3 21, you can divide them both by 3. 7's down below. 8 and 4, divide them both by 4. Then you're left with a 2 up above. It's going to give you 2y to the 4th over 7x. On 20, you're going to take your time on this page, factor out the 5 that they have in common, first numerator. First denominator, factor out the 6 they have in common. Then you got to flip it. Take out the 7 they have in common here. So the x plus 4's cancel, the x minus 2's cancel. You're left with 35 over 6. Take out the 3 they have in common, 14x. Remember, when you have division, you're going to multiply by the reciprocal. Factor out the 6 they have in common here. The x plus 2's will cancel, the x's will cancel. And then 3 over 6 is just 2 down below. 7 over 14 is just 2 down below. 2 times 2 is 4. If everything cancels in the numerator, that's really a 1. All right, here on 22, multiplies to 15, adds to 8, 5 and 3. 1 multiplies to 20, adds to 9, 5 and 4. The x plus 5's cancel. You have one more x up top, so that x goes bye-bye. 6 divided by 4 is 3 over 2. Remember, there's an x there, so it's 3x times x plus 3 over 2 times x plus 4. Then on 23, difference of two perfect squares. That's how it's factors. The x plus 2 cancel. 3x is north, 2 south, so those two cancel with that one. 5x times x minus 2 all over 3. All right, and that's really, for some of us, the harder page. When you add and subtract fractions, you need the same denominator, which you have on 24 and 25, so simply put them together. As on 26, you got to make the denominators the same. This 5 needs to be made into 10, so give it a 2 over 2. This has 3 x's, so this needs 2 more x's. That's why I give it x squared over x squared. This has 3 y's. This needs another y. That's why you give it y over y. 4 times 2x squared is 8x squared. 3 times y is 3y. That's how it goes together. This has an x minus 3. It needs an x plus 3. So give north and south an x plus 3. That has the x plus 3. It needs the x minus 3. So give north and south the x minus 3. Use distribution. Simplify it. That's your answer. Call 4 over 1, so it simply needs that denominator, north and south, get an x squared minus 5. Use distribution and simplify to get your answer. Here, guys, you have two fractions that you are dividing, so simply multiply by the reciprocal of what you're dividing by. So flip it. 2 times 2x plus 3 is 4x plus 6. And 5 times 3x minus 5 is 15x minus 25. It shouldn't be that bad of a page. Now I'm doing the same thing here. If you want to make 5 and a 10, give it a 2 over 2. Remember, simplify fully, so 10x over 10 is just x. Here, you're going to have to factor both denominators and see what their individual parts are. Notice they both have an x plus 3. This has an x minus 3, this one doesn't, so give it an x minus 3 over x minus 3. This has an x plus 2, this one doesn't, so give it an x plus 2 over x plus 2. Use distribution, then put them together. That's your answer. All right, on this one, that's supposed to be an x squared minus 9. That's not written well. Got x minus 3, x plus 3. This one had the x minus 3, so it simply just needs the other x plus 3. Use distribution, add them together, simplify, that's your answer. And lastly, on 33 here, factor out the 2 they have in common. X minus 4, they both have. This one has a 2, this one does not have a 2, so give it a 2 over 2. This has an x plus 4, that does not have an x plus 4, so give it x plus 4 over x plus 4. Use distribution and do 2 times 4 is 8. That's your answer. Simply cross multiply, check your solution, make sure here you don't get x is 0, you don't. Cross multiply, again, those should be very easy. Remember, an extraneous solution is a solution that makes the denominator 0. That's a math sin. And lastly, as we pause, we're brought to you today by Stanley. Stan, the little man right there, say hi. All right. Number 37. Cross multiply again. Just take your time. Make sure you don't get a solution that gives you 0 in the denominator, which you don't get on these few here. Again, 37 through 39 should not be an issue. You got to make the denominators the same on 40 through 43 here at the end. So factor this one. You got x minus 5, x plus 2. This guy needs x plus 2 over x plus 2. This one needs the x minus 5 over x minus 5. When all the denominators are the same, then the numerators make a true statement. So 3 times this equals 2 times that plus 17. The only extraneous, and Stan just whacked the pen out of the hand, so there goes the pen. The only extraneous solutions would be x equals -2 and x equals 5, which we don't get, so x equals 1 is totally fine. Call 5 over 1, then the common denominator would be 8, right? Because 5, I can make 1, 4, and 8 into 8. So double 4, multiply 1 by 8. So then you're going to get 3x plus 6x is 40. X is 40 over 9. Guys, what I would do here is I'd subtract 8 from both sides. If that's a negative, attach it with the 3. Then you can simply cross multiply because 6 is 6 over 1. If you got x is -2, that would be extraneous. That is close, but that's not -2. Here, folks, if that has x minus 3, that has x minus 3, well, then x over 1 needs an x minus 3 over x minus 3. Use distribution, the x squareds will cancel, giving you x is -1. If you got a solution of x equals 3, that would be extraneous. That one's not. That's how you check. All right. Open note test is on Tuesday. On Tuesday, when you have this, it will be tomorrow. This is 90.9, the Quadratic, signing out.